Hello everyone, my name is Nandini Singh and today I am going to walk you through a concept that every operating system must handle behind the scenes. How files are actually stored on disk. But instead of jumping straight into blocks and pointers, I am going to tell the story of a city library because it perfectly mirrors how file allocation works inside an OS. The library. So imagine a huge, busy city library filled with thousands of books. In our story, every book represents a file that you store on your computer. The librarian acts like the operating system, and the long bookshelves are like disk storage. Whenever a new book arrives, the librarian has to decide exactly where to place it so that it can be found quickly and efficiently later. This simple decision inside a library is very similar to what the OS does every time you create or save a file. But now we move on to the library's shelving dilemma. That is, over time, the library gets messy, books are borrowed, returned, rearranged, or replaced. Shelves that were once neatly organized now have random gaps. Some shelves get crowded, and sometimes a book doesn't fit where it originally belonged. If you look at it from a technical perspective, the same thing happens on disk. Files grow and shrink, some get deleted, and free spaces become scattered in random places. So, just like the librarian needs a systematic approach to shelving books, the operating system also needs smart methods to place file blocks on the disk. This leads us to the three main allocation strategies. The first strategy is called contiguous allocation. Picture the librarian finding a long empty shelf and placing an entire encyclopedia set, all volumes from beginning to end, right next to each other with no gaps. Everything is neatly arranged in one continuous stretch. This makes it incredibly easy to read the set. You simply start at the first volume and move across straight. The OS behaves the same way. It stores all part of a file in consecutive disk blocks. But although this looks very organized, it comes with problems. The librarian needs a large empty shelf to accommodate the entire set, and if a new volume is released later, there may not be any free space next to the existing ones. So in computer terms, this leads to external fragmentation, where small unused gaps appear across the disk. So now we move on to what a contiguous allocation looks on disk. File A uses block 2, 3 and 4 and file B occupies block 9 to 13 and so on. Everything belonging to a file is placed together. This makes access extremely fast, but only when enough continuous free space exists, which becomes less likely as the disk fills up or file starts changing in size. So when the librarian can't find a long empty shelf, he switches it to another method called linked allocation. In this method, the librarian doesn't worry about keeping the volumes of a book together. He might put volume 1 on shelf A, volume 2 on shelf K, and volume 3 somewhere completely different. The trick is that he leaves a sticky note inside each volume that points to the shelf where the next volume is kept. This method is flexible and never requires a big continuous space. Files can grow easily because the operating system can simply link a new block anywhere on the disk. But there's a downside. If you want to jump directly to volume 5, you can't. You have to follow each sticky note one by one. And if even one sticky note is lost, the chain breaks and the rest of the file becomes inaccessible. So in this diagram on this slide, you can see exactly how that works. The file Jeep is stored in random blocks across the disk, and each block contains a pointer to the next one. The final block has a negative pointer, meaning the file ends here. This avoids fragmentation but sacrifices fast random access. So next we move on to the third method, that is index allocation, which you can think of as a librarian creating a catalog card for each book. This card lists the shelf number of every volume, so even if the volumes are scattered all over the library, the librarian can instantly look at the card and know where each one is stored. The OS does something very similar. Instead of linking blocks, it creates a special index block that contains the address of every file block. This means you can jump directly to any part of the file, which is incredibly fast. However, this does require extra space because you have to maintain the index, and every large files may need more than one index block. Now, this slide shows how the index block works. Each file has its own index, and each entry in the index points to a specific disk block. The directory only needs to store the address of that index, making access very efficient. At this point, you might wonder, does one method outperform the others? Well, not exactly. Each method has its own strength and is best suited for different types of files. Small, fixed size files work well with contiguous allocation. Files that grow constantly benefit from linked allocation, and files requiring quick access often use indexed allocation. Modern file systems like NTFS and Extension 14 even combine multiple methods to get the best of all worlds. Now, this slide brings our entire library metaphor together. The encyclopedia stored side by side represents contiguous allocation, the scattered books with sticky notes represent linked allocation, and the catalog card listing all shelf numbers represent indexed allocation. This simple library story makes it easier to visualize how an amazing system handles files internally. To summarize the technical details, continuous allocation offers fast and simple access but suffers from fragmentation. Linked allocation avoids fragmentation and allows flexible growth but is slow for random access. Indexed allocation supports direct access and avoids pointer chains but requires extra indexing space. These three strategies form the foundation of file system implementation in operating systems. Thank you so much for listening. Just like a good librarian keeps the library organized and easy to navigate, a good operating system silently organizes your files every second and you use your computer. The library may close, but the OS never stops working. Thank you.